Hi, my name is Henry, and our team is honored to participate in the second round of the UBS Innovation Challenge. We have assembled an excellent team for this project, and our team consists of my partner, Joseph, and myself. I graduated from NYU Stern with a degree in Finance and Economics, and previously worked in investment banking at Goldman Sachs, where I was part of the Equity Capital Markets Group. For this project, I am in charge of the overall product vision as well as business development. Joseph graduated from Harvard with a degree in math and has over 3 years of experience as a researcher at the Harvard School of Public Health, focusing on machine learning and predictive analytics. He's in charge of building our technology stack and the machine learning algorithms behind our product. We are both currently full-time entrepreneurs in the US, and we're excited to show you our demo. Here you see a client portal where users can receive personalized, curated financial information. When a user logs in for the first time, he or she is taken to the Preferences and Settings screen, where a series of questions can be answered to determine the user's investment profile. This is used to establish the baseline for content curation. You can see here that there are some questions regarding time horizon and risk tolerance that the user can answer to initially profile the client. Once these settings are set, this takes us to the home page, which is a newsfeed style page that ranks information in order of relevance. On the left-hand side, there are tabs where you can filter different types of information, such as market news and even research. The portal tracks how the user interacts with the content, such as whether or not the user viewed the information and the duration of the interaction, and make corresponding changes to the ranking algorithm to improve content relevance. For example, if I click on this research piece regarding bond portfolios, the algorithm will learn that I am more likely to be interested in fixed income products, and will adjust my preferences to show me related information, such as interest rates. To give you a sense of what goes on in the algorithm to rank the information, we've also prepared a small demo in Excel to further explain the process. In this Excel demo of the algorithmic process, we have 3 different pieces of information and 3 different users. The goal is to rank the information in order of relevance for each user. At the core of this is a matching process in which the information is indexed based on specific factors and then presented to the user. Here we have several different attributes used to describe each piece of information and each user: their time horizon, risk, and sector preference. For simplicity, we've broken down the sectors into tech and non-tech. Then a total information score is calculated for each piece of information by taking the average of these different attribute scores. Similarly, a total user score is calculated for each user, but instead we use a weighted average to capture how the user perceives the importance of these attributes in relation to one another, by taking advantage of this weightings matrix below. Once that is calculated, we can generate a relevance matrix, which basically describes how well each piece of information matches with a particular user. We can express this matching by using an absolute value function that shows the distance between the information score and the user score. Once that is calculated, we simply prioritize the information that have the closest score to the user's preference score, as shown in the recommendation output here in green. User interaction will change preferences and weightings. So say if I change the time horizon attribute for user 2 from 1 to 10, you can see at the bottom that the ranking for user 2's information has changed as well. Similarly, if I change the weightings for user 2 and switch these 2 different weightings, you can see that user 2's information ranking has adjusted accordingly. Another thing to note is that we use collaborative filtering in our algorithm to infer information when data is not available. For example, if user 3's sector preference data is not available, if I just delete these 2 cells, we can then look to user 1 who has similar time horizon and risk attribute scores to that of user 3, and can then infer that, hey, user 3's sector preference scores might be similar to that of user 1. This is used to fill in the missing holes in our dataset to generate a baseline for recommendation. As we have more users, we can take a weighted average of the sector preference of similar users to user 3 to create an even more accurate inference. This concludes our presentation and demo. We believe that our team's intersection of finance and data science backgrounds will bring tremendous value to this project, and we are excited to have a chance to bring our product vision to life. Thank you.